Hi everyone. I've got a modeling problem today that doesn't involve temperatures or population levels or predicting anything at all, actually. It's more of an engineering problem. I'm trying to build some animation software, and one of the basic things that you do in animation is move things from one point to another. So here, for example, is an ellipse that's moving from one side of the screen to another at a constant speed. So the way I made it do that was I actually computed an exact function that would tell me its x position at every single frame of the animation. So I told it where I wanted it to be at a certain time in frames. So I think it started at frame 20, and I think it ended at maybe frame 120. And this x position is its x coordinate on the screen. So it started at, I think it might have been 300 and ended at 500, something like that. And if I want it to go at a constant speed, I know I want it to start here and end there, and so I can just connect it with a straight line. So all I really needed to do was compute this function. And then I would ask it at every single frame, at this particular time, what's your x position, and then I would use that to draw the ellipse. But if I want a kind of zippier animation, I don't want it to just move at a constant rate. I want it to start slow and speed up and then slow down again at the end, something kind of like this. Okay, so if I'm going to apply the same approach, that means I need a function, and the function needs to connect this point and that point, but it needs to fill in the inner points in a different way. Because I'm not moving at a constant rate, I need to figure out what curve tells me to start out slowly and then accelerate and then decelerate. So if you want to, you can take a minute and fill in your own curve that you think will produce that motion. Here's what I'm thinking. I'm thinking I want the curve to be symmetric, so at exactly halfway through the available time, it should be exactly halfway to its end goal, so here. But then I want it to start out slowly, so more time passes with not a lot of x position change, and then it'll sort of symmetrically complete up there. So I want a curve that looks something like this. So that's the task. This is with a particular example, but we want to be able to do this in general. So if I give you 2 points in the plane, AB and CD, so this is points AB, this is point CD, I want you to give me a nice equation that will connect the points with a shape that looks something like this, whatever that means to you. So it should be symmetric, and it should be kind of curvy, and it should have a point of inflection in the middle here. And if we want to be able to control our animation, it would also be nice if we could control kind of how fast it accelerates and decelerates. So for example, if we wanted it to start out slower and accelerate quicker, we might try something like this. So it's got the same shape, only more extreme. Or if we wanted the motion to be less extreme, we could do, well, that wasn't a very good drawing, but we could do that kind of thing. So you're allowed to use whatever families of function you want. You can use whatever mathematical tricks you want, but that's the end goal. And the basic version, just give me anything at all that looks like this. If you want to try and be a little bit more advanced, you could try and include some parameter where you give it a number that controls kind of how steep it is in the middle here. Or you could also add other parameters, like for example, I might not want the tangent line here to be perfectly flat every single time I hit this point, because that implies that I start out moving very slowly. You might want to be able to supply a parameter that tells me what's the slope when I start and when I end, which is like telling me kind of how fast do I start moving prior to my acceleration and deceleration. I myself have explored 3 completely different solution approaches to this problem, and I think none of them is perfect. Like, I haven't found one that I think is clearly better than all the others. Each one has its own pros and cons. So I think that's the mark of a really nice, rich problem. And I'm sure there are approaches that I haven't thought of that are worth investigating. So good luck. If you find something interesting, I would like to know, because I'm still writing the software.